Hey, good afternoon. This is Mrs. Rubin here at Rhoades Elementary, 5th grade classroom. We're going to learn about the solar system today with Mr. Crosslin. Yay!
What is the solar system? Well, I'll tell you. Let's break that down. Solar system. Kind of like when we study the body systems, like the skeletal system had bones, right? So the circulatory system had heart, veins, arteries,
lungs,
capillaries. So let me ask you a question. What is in the solar system? The sun. It's called the solar system. In fact, the solar system has to do with, here's a model of the solar system, and it has the sun and the 9 planets. Actually, 8 planets. I used to get quite upset because for many years I thought Pluto was a planet. But they changed the definition of a planet. They actually used telescopes from, here's Earth, and they noticed that way, way out here, where Pluto is, there were 5,000 other things like Pluto. So either they come up with 5,000 new names, or they decide, wait a minute, this is not a planet any longer. It is a, anybody know? A dwarf planet, or a planetoid. So unfortunately, we don't get to call that a planet anymore, but we do have these other 8 planets and the asteroid belt. And I used to remember these like this. My very eager mom just served us 9 pizzas. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and, well, forget about the pizza, Pluto. My very eager mother just served us nachos. All right, so this is kind of cool. This is a model because these things, there's a name for it. What do you call it when things go around the sun?
rotation.
It's not a rotation. They revolve. Very good. Or orbit. Very good. This is an orbit or revolving. And you notice some of them are closer, and like Mercury, it takes about 88 days to go around the sun. What about the Earth? 365. You guys are probably 9, 10, or 11 years old, right?
Yeah.
When you were born, if the sun was here and the Earth was here, you've been around the sun 9 times already. Every time you go around, you have a birthday. Now, good thing you don't live out here on Neptune, which takes over 100 years or longer to go around the sun. You would never have a birthday. Your parents would save a lot of money on cake and candles, I'll tell you. Now, you're going to learn in this lesson that the solar system, really, the sun holds the planets in orbit by a force called gravity. And so these things, as they orbit, they don't fly off into space because the sun is pulling on them. But the weird thing is, they're actually pulling on the sun. But in gravity, the big win. And the sun is much bigger than the planets. Now, if these were not being held by gravity, can you imagine if I swirled something around? Can I borrow your necklace? Yes. Let's bring it over here. Let me show you what I mean. And hopefully I won't break it. Okay, so here is a model. Check this out. Here is, my hand is the sun, and the planets are orbiting. What's holding them together is the gravity. Now, if I let go of this, if gravity stops, what's going to happen to the planets? Get ready, because we're going to end the solar system. 3, 2, 1. I'm going to let go of gravity, and let me see that. Please be careful. Don't pull on it. Luckily, as the planets are going around, the gravity of the sun is holding them together. Because if not, we'd be in big trouble if all of a sudden we broke the gravity and we left the solar system, where it's cold, dark, and no life. In fact, not life that we know. In fact, the inner planets are close to the sun. The outer planets are farther away. In between is the asteroid belt. So let's take a look at these inner planets. 3 of them are too close to the sun. They are very hot. Mercury, forget about it. Venus doesn't have a magnetic sphere around it to protect it. The sun has burned off its atmosphere a long time ago. In fact, the Russians actually sent a spaceship that landed on Venus. Pressure is so big, it's crushed it. Heat is so big, it melted it. And by the way, the atmosphere is made of acid. They took a picture, it lasted a few minutes, and the whole spaceship melted. Don't want to go to Mercury, don't want to go to Venus. But Earth is just right. So here is like Mama Bear, Baby Bear, Goldilocks, Papa Bear, forget it, it's too cold. So we call the Earth the Goldilocks planet because it's just right. Now our sun, you're going to learn next week when you study the sun, is giant, but it's relatively small as suns and stars go. So this is a solar system. It shows the sun holding everything together and things orbiting the sun and the planets. I'll tell you, something really cool happened in the 70s. There was a spaceship, the scientists decided that if we built a spaceship, all the planets, they're never lined up like this. Well, maybe once in a million years. And they were coming around. And we launched a rocket called Voyager. Voyager took off and it headed towards the planets. At first, Mars came by and it flew by Mars. Then Jupiter, see, it's going in a straight line. And then Saturn came by. This was called the Grand Journey because they launched it in 1976 or 7, I think, and it was launched right when all the planets were coming by. And the last couple planets, it turned around and took pictures, and Voyager is still sending back information to Earth. And it was launched in the 70s. And it's now the only thing that's ever left our solar system. And that's pretty cool. But I'll tell you,
We saw videos of it.
of the Voyager. But I'm telling you, everything I've been telling you, Mrs. Rubin, and your class, everything I've been showing you, I hate to say this, kids, but this model is a lie. Okay, so what do I mean by a lie? Most of the time when you see a picture of the solar system in a book or on the internet, you see the sun right here like this, right? And then you see the planets like next to it, and usually Mercury, Venus, Earth, Mars, and then Jupiter, Saturn, Jupiter and then Saturn, and then we see Neptune, and we see them like this. There's 2 things wrong with this picture. 2 things wrong. One, the scale of distance and 2, the scale of size. Now, what do I mean by that? All right, here's what I mean by that. If the sun was this large, if the sun was that large, the Earth would only be this big compared to it. Did you see that?
No.
The Earth would only be that big compared to it. Let me show you what Mercury would look like. Mercury would look like that. In fact, Jupiter, here's the problem. If the Earth was the size of a marble, if we made the Earth this big right here, size of a marble, we'd have to make the sun about 5 or 6 feet in diameter. And what I mean is, if I was the sun, the Earth would be the size of this cap. So it's hard to draw that in a book or in a picture. You guys know what this is, right? Watch, let me show you. You know what this is?
Christmas tree?
A Christmas tree or a tree, right?
Yeah.
Are they only that big?
No.
No, they're about 8 feet tall, right? I just drew that to a scale that 1 inch equals 1 foot. So if I use the scale 1 inch equals 1 foot, how tall was my drawing? That's 8 feet?
8 inches.
This would be 8 feet in real, 8 inches on the drawing. You understand that? You guys ever play with Barbies or dolls? Tell the truth, man.
No.
You've never played with a Barbie?
How about
Okay.
an Avenger?
How about
Wrestler man.
a wrestler man? Okay.
Show.
Big Show. Big Show, big guy, right? Now, Big Show, when you go buy Big Show, you know, I'm not really good at drawing muscle man, but, you know, here we go.
Muscle.
Here's our muscle man, you know. They usually have real little legs. Here's our muscle man, right? Does he have hair? Does Big Show? Oh, you got hair now. Okay. So Big Show, it's really not that big, right?
No.
In real life, he's bigger. So we used a scale drawing. That's one thing. So the scale of size is wrong. The other thing is the distance. If the sun was this big, the first planet would have to be over 100 meters away. And Neptune would be 5 miles from here. I mean 5 miles from here. If we drew the sun this big, we'd have to put Neptune over at Ben Davis High School. Now, I can tell you about this, but let me show you a video that does a much better job of the scale of the solar system.
The Earth diminished in size. Finally, it shrank to the size of a marble, the most beautiful marble you can imagine. Seeing this has to change a man. James Irwin, Apollo 15 mission.
If you look up an image of the Earth and Moon, you're going to get a picture where they're quite close together. Something like that. But in reality, the Earth and Moon are about that far apart. That is the Earth and the Moon to scale. That tiny light out there is our sun, just over a mile away.
Okay, so that video, if you want to watch it again, it's called To Scale, the solar system. And it is really amazing because it shows you the true scale if you want to make a model of the solar system. There's only been 24 people that have seen the Earth from that distance. And those were the Apollo astronauts that headed towards the moon. And they looked out the window and saw back the Earth and the true scale of it. So we really can't go out in the desert and take 7 miles to make a scale model. So we're going to have to use a different scale. And we're going to make a model in your hallway here. Okay? And the model we're going to use, so we're going to make a model solar system from the sun. We're not going to worry about the size. In fact, we're not even going to have the planets. Next week, the lesson is about the size of the planets. This is about from the sun. And so this is going to be the sun right here. You're going to use a scale. We're going to get into teams, all right? You're going to get some paper, strips of paper. And these strips of paper, you're going to put them down the hallway. And some of these strips of paper are going to be longer than others because some of these strips of paper are going to be inner planets and some will be outer planets. Now, this is going to be kind of easy to do, but it's going to take some math. And so here's the first thing you need to do. We're going to be in teams, and you're going to use strips, and you're going to mark off on each strip every meter. So every meter you're going to mark from here is 0, 1, 2. And you're going to find that the inner planets are not even going to be a meter away. But some of the outer planets, like the longest one, is going to be over 20 meters down the hallway. That's 20 big steps. So whoever has You're going to have a lot of these, going and going and going. Okay? So what scale are we going to use? Look in your book. There's a scale right there. We're going to use 1 centimeter equals, someone want to read it for me? It's right there on the bottom of that little chart. 1 centimeter equals how many kilometers? 1,940,000 kilometers. Now you know that a kilometer is 1,000 meters. So this is the scale we're going to use. 1 centimeter equals 1,940,000 kilometers. And they've already done the math for you. So your job is to write the name of these planets. Let's say this might be Earth. Write the scale on that strip. 1 centimeter equals 1,940,000 kilometers. And to mark off each meter. Then we're going to take these in the hallway and see if we can make our own scale version. And remember, our scale is 1 centimeter equals 1,940,000 kilometers. Okay, you want to get started?
Yes.
Okay. Okay, so here's your deal. Each team is going to get a meter stick. Be careful of these. They do come undone, but they break easily. Here's 1 meter stick. You're going to need that. You're going to need your book. Each team will get a roll of adding machine paper. And each team will get some tape to tape it down. So we'll put out in the hallway a mark from where the sun is, and you will come get your materials. Send 1 person from each team, and let's get started.
Hey, we're doing the outer planets. Jupiter,
Right here.
Uranus, Neptune. Oh yeah, Saturn.
So the outer planets are doing a good job. Let's go check out the inner planets.
We have Earth as our planet, and in the scale it would be 77 centimeters, and 1 centimeter in space, I'm guessing, would be 1,940,000 kilometers. Now I'm going to label it Earth because that is our planet.
And how many centimeters from the sun would it be in our model?
Right there, 77.
77. Very cool.
Guess we have to add to the model.
Ours right.
Look, you can see it's getting longer and longer. I picked a boy.
Why do you feel so lonely?
I the pin.
You're Neptune? And look how far away you are, Neptune. No wonder you're out here by yourself. 23 meters. Wow. See you later. Hey, Neptune, can you hear me down there? Wave. That is a long way away. Hello down there.
Hello.
Hey, I'm at Neptune, which is 23 meters from the sun in our
Maddie?
scale. Good thing we didn't do Pluto because it would be another 50 meters out the building. But the outer planets are really far away from the sun. Oh, finally, Uranus. Oh, and I'm still in the outer planets. Who's next after Uranus? Saturn. Still too far. And finally, Jupiter. But I'm still by spaceship years away from the Earth. Let's keep going, and finally, the inner planets. Mars, we have some aliens coming through. Really? UFOs. And these are the inner planets, and those are the outer planets. So we made a scale of distances. This gives you some idea how to make a real scale of the solar system. Mercury is this far from the sun. Neptune, way down there. Good job, guys. Give yourself a round of applause.